Okay, hello everyone. Today we'll be talking about how you can use Excel to solve CMAL equations. So perhaps your first thought is that a graphing calculator can do the same job by its polyCMAL function, but actually that can only solve linear CMAL equations, while this Excel numerical method is not restricted, so it can also solve non-linear CMAL equations. So how does it work? So for this example, I have used three unknown variables, x, y, and z, but in fact, you can have any number of unknown variables. But for n number of unknown variables, you would need at least n equations to be able to solve for the unknowns. Okay, so for this example, we have three functions, and what we do is we manipulate them so that they all are equated to 0, and then we can use Excel from there. Okay, the technique is to minimize the sum of the squares of all three of the equations. So theoretically, if you have gotten the answer, it should be 0, because it will be 0 squared plus 0 squared plus 0 squared, which will be 0. And this method works is because the square of any number must be non-negative. So the true minimum or the global minimum would be 0, and it cannot be a negative number. Okay, so let's look at this example. X to the power of y to the power of z is equals to 2, y to the power of z to the power of x is equals to 3, and z to the power of x to the power of y is equals to 4. So we rearrange them to get these three expressions, which should all be equal to 0. So what we do is we minimize equation 1 squared plus equation 2 squared plus equation 3 squared, which should be 0. And so what we do is now we can use the solver function in Excel, which I will show you now. Okay, now we are in Excel, and I will show you how this solver method works. So in this data tab, some of you might have this solver over here. It's not automatically installed into Excel, so you have to download it. You can watch some other YouTube videos on how to download this solver function into your Excel. So over here, we have our three variables, x, y, and z, and our three equations. So for equation 1, what I did is I wrote x to the power of y to the power of z minus 2, and then second equation, y to the power of z to the power of x minus 3, and the third equation, z to the power of x to the power of y minus 4. So if we have solved for x, y, and z correctly, all these three equations should be equal to 0. But I mean, it's just an initial guess. The values 1, 1, and 1, so it's very unlikely to be actually correct. And here we can see that they're not 0, and hence the sum of the squared values is clearly much more than 0. So what we do now is we click on solver and we set the objective to be this G7, the sum of the squared. So we want to minimize it by changing the variable cells x, y, and z. And then we click solve. And yes, now the results are out. Okay. And here you can see that the sum of the squared values is 5.28 times 10 to the power of minus 11, which is really, really close to 0. So that's good. It means we got the answer. So now we can see what x, y, and z are. So x will be 1.37, around there. Y will be around 1.38. And z will be around 2.45. So that is the answer. And a graphing calculator would really struggle to do this because they can only solve linear Simul equations, and even the grapher form can only do it in 2 variables, while this is a 3 variable equation. So it shows the power of Excel in this solver method used to solve it. Okay, that's all I have. See you in the next video.